All right. The graphs below represent the motion of a particle with position x, y. Sketch the graph of the following by converting the equation to rectangular form or by eliminating the parameter. And by the way, a lot of times these are also represented, instead of writing them like this, they'll just write them as 2 minus t squared, comma, 3 plus 2t, or they'll even make it a vector and put our little vector symbols on there. Now the question here was to convert this to rectangular. So what you do is you solve one of the equations for one of the variables. In this case, since both of them have a t squared in, I'm going to solve this first one here for t squared. So solving this for t squared, that would give me t squared would equal 2 minus x. And now I can shove that into the y. So this will give me y equals 3 plus 2 times, instead of t squared, I'm going to put 2 minus x. And now I clean that up. So that gives me y equals 3 plus 4 minus 2x. So y equals 7 minus 2x. So if you look at that, this looks like the equation of a line. Equation of a line. So the question is that what this graph is going to be? So here's where we have to do our analysis. Now, t was the variable. There's no restrictions on t up here, so usually I should talk about the domain, and I forgot that right here, so we'll write that. The domain here would be t can be all real numbers. Okay. Now, since t can be all real numbers, let's think about what happens as t goes to infinity. As t goes to infinity, as t gets really, really large, what happens to x? Well, hopefully you realize that this is a parabola. If I was drawing my x versus t, or t versus x graph, this would be a parabola that's heading down. So as my t goes to infinity, my x is going to negative infinity. And then down here, that was t goes to negative infinity. I did the bottom one. But they both actually go to negative infinity in this case. As t goes to positive infinity, it also goes to negative infinity. So as t went to negative infinity, so did x. And as t went to positive infinity, so did x. X went to negative infinity. All right. If we look at the other one, the y equation, hopefully the y equation, you recognize that's a parabola that's been shifted 3 units up. And here, as t goes to infinity, the y value is going to infinity. And as t goes to negative infinity, the y value is going to infinity. So what this tells us, we can look at these little graphs. So looking back at this orange graph, we can see that the range of x here would be, the furthest it would go down is negative infinity, and the highest it would go is to that 2. So negative infinity to 2. The range of y would be, it would go to that 3, right? That's right there. Would be the lowest it can go, and then it goes up. So that's 3 to infinity. So that tells me I'm not getting the whole line. Because if it's getting the whole line, that line would go from negative infinity to infinity for both the x and the y. So now we got to figure out what's happening. And usually it's this point that where these turned around at. So on this one, this was at t equals 0, and on this one, it was at t equals 0. So let's make a little chart. T, x, and y. And I want to look at 0, but I usually want to look before and right after. So if I plug those in, if I plug in negative 1 into the x, I get 2 minus 1, so that's 1. And into the y, I get 3 plus 2, that's 5. If I plug in 0, I get 2, 3. And if I plug in positive 1, I get 1, 5. So now let's plot those points. So the first point is 1, 5. So 1, 5, that's right here. Okay. Then it goes to the point 2, 3. So 2, 3, that's here. So we can already see that it's heading down this direction. And then it goes to the point 1, 5 again. So it comes back to there. So what has happened, and maybe we need more points for this, for you to see this, but it's actually come down to here, and then it goes back. So its orientation is, it turns itself around at the point 2, 3. It doesn't go any lower than 2, and we said that for the x's. They wouldn't go any lower than, or any bigger than 2, and the y values don't go any lower than 3. So here's another one. We want to eliminate the parameter. So first of all, I'd probably rewrite x here as 1 over e to the t using my exponent rules. And then I can see that that means e to the t would be 1 over x. So now I can substitute that into this equation, so that will tell me y now will equal 1 over x. And we know that y equals 1 over x looks like this, but the question is, do we get that entire graph? And to figure that out, we need to think about each of these graphs. So t versus x. Hopefully you remember that the e to the negative graph is an exponential decay, so it looks like this. So we can see here that as t goes to infinity, x is going to 0, and as t goes to negative infinity, x is going to infinity. And we can also see that from the graph. So that means the range of x here is going to be 0 not included up to infinity. Then we can look at the y equation, which was this one, y equals e to the t. Hopefully you remember that's an exponential growth curve, so that looks like this. So in this one, as t goes to infinity, y goes to infinity, and as t goes to negative infinity, y goes to 0. So that also has a range of 0, infinity. Now what that tells me is that the y's and the x's must both be positive. So that means we're not getting the lower part, we're only getting the upper part. So it looks something like this. The question is, what's the orientation? So we could plot some points. The question is, what points would you want to plot? Well, you always want to plot points that are easy to graph. So if I would probably do 1 over e, 1, and e. So when you plug 1 over e into e to the minus t, whoops, those are not the points I would do. I'd do negative 1, 0, and 1. Sorry. If you plug in negative 1, you get x is e, and y is e to the negative 1, which is 1 over e. That's where I got my numbers. I was looking at that. If I plugged in 0, I get anything to the 0 power is 1, so these give you 1, 1. And if you plug in 1, you get 1 over e and e. So if you plot those, we know that the first point would be e, which is like 2.71, and then 1 over e. So 2.71, 1 over e is some small number, so that's somewhere in here. And then we get the 0.11, which is right there. And then next one we get a small, really small x, and 2.71 for the y. So we can see this thing is moving in this direction. All right, this one's the same thing. So in this case, we'll have to solve this the whole way for one of the variables. So I'm going to solve this for t in terms of x. So t would simply equal x to the 1/3. And now I'll plug that into the y equation. So y will come out to equal 3 times the natural log of x to the 1/3. But then I can use exponent rules, or the log rules, and rewrite this as y equals 3 times 1/3 the log of x. And of course the 3 and the 1/3 cancel, and so this just gives me y equals the log of x. And we know that y equals the log of x in and of itself. If we did an x versus y graph, which is what we'll eventually have over here, I just want to make, this is before I consider everything. This is the most it could be, and it might be all of that. If we looked at x versus t, now this is the first one where we're actually going to have to consider the domain, because the domain of t here, the domain of the functions, is t has to be greater than 0, because you can't take the log of 0. So based on that, then the graph of x versus t, or t versus x, generally the x cubed equation or the t cubed equation would look like this. However, because our domain is restricted, this part of the graph never shows up, so we just get this. So as t goes to infinity, x goes to infinity. And as t, here we can only consider 0 because we can't, negative infinity is not part of our domain. So as t goes to 0, x goes to 0. Then we want to do the same type of thing for the y equation, but nicely the y equation, y equals 3 log of t. Oops, this is t. That's simply going to look like a regular old log equation, because that's defined, that the domain of that is t from 0 to infinity. Sorry. So again, looking at this, as t goes to infinity, the y value goes to infinity, and as t goes to 0, the y value goes to negative infinity. So we should get all the possible y values. That's what this tells me. So that means I'm going to get all of these, so that is strong evidence that I'm going to get the whole graph. So over here I know this thing's going to look something like this. The only thing I need to know now is the orientation, and the easiest thing to do there would be maybe plot some points. And this time the points I would plot would be 1 over e, 1, and e, x and y. The x value won't be particularly nice. 1 over e cubed is just 1 over e cubed. And then when you plug 1 over e into the log, that gives you negative 3. If you plug 1 in, 1 cubed is 1, and the log of 1 is 0. And if you plug in e, we get e cubed, and this will give me 3. So if you plot those points, the first one's a really small x with a negative 3. Then we get the point 1, 0. Then e cubed, which is 2 point something cubed, which is going to be big, and 3, so that's going to be somewhere up in here. So in other words, this thing is doing that. I'm going to jump to example 8 here. This one says x equals 3 cosine of t, y equals 3 sine of t. The trick to changing this to rectangular form is that you have to use the trig identity that cosine squared of t plus sine squared of t is equal to 1. So first you have to take each of these equations and solve them for cosine and sine. So we can see that the cosine of t would simply be equal to x divided by 3, and the sine of t would equal y divided by 3. And now I'll plug these into this equation. So this one would become x squared over 9, because you're squaring this whole thing, plus this one will become y squared over 9 equals 1. If we multiply that whole thing by 9, we get x squared plus y squared equals 9, and hopefully you know that that's a circle centered at the origin with a radius of 3. And to plot it, you would make a t-chart, and I would plot the quadrantals. 0, pi over 2, pi, 3 pi over 2. So I plotted those points for you. or plug those in. So those would give me 3, 0 at t equals 0.